off with all of my angles. So we start off with 0. Then this is how many later? 90. Then another 90 gets me to 180. And then another 180, or another 90 gets me to. And then another 90 gets me to 360. Then I do all my 30s because I'm a rebel without a cause, and I like doing things in sequential order, which is not what a rebel would do, but pretend I am. Okay, cool. So this is 30. Yay! Then this is 180, and then this would be 30 less than it, so it would be 150. Good math. And then this would be 30 more. 210. And then this would be 30 less. 330. We are all rock stars. Cool. We did all the 30s. Now we do the 45s. Ready? This one's 45. This one is 45 less than 180, which is 135. And this is 45 more than 180. 225. And this is 45 less than 360. 315. What's the only angle I have left? 60. What? Oh, it's okay. Oh, I didn't know what was going on. You had blinders on, and okay, good. I'm glad this is. I didn't know. I'm glad you explained it to me. I was very confused, but now I am.
Just assume I'm doing that thing.
No, it was Taisei behind you doing this. That was confusing me. It wasn't you. He was putting his binoculars on because it's so much easier to see, you know? All right. So this is 60. You telling me you wouldn't question if someone was staring at you like this? Yeah. You're a little worried. All right, but he's good. Thank you. Zoned in. You can zone back in. Sorry, I totally ruined that for you. 180 minus 60. 120. Good answer, guys. Good job. Thanks for the help. And then 180 plus 60. 240. And then 360 minus 60. 300. Seems the 60s have caught you guys off guard a little bit, but they're just the same thing. Okay? Now, paying attention. Cool thing about the unit circle. Ooh. Nothing to see here. Cool thing about the unit circle. The unit circle has a radius of 1. The unit circle has a radius of 1. Yes. No, sorry. Good job. Thank you. You were affirming my greatness. So yes, unit circle radius of 1. Totally affirming it. So the next place I go when I'm doing any coordinates is I go to the armed ones because it has a radius of 1. True statement. So here, what is this? This is the part that blows my mind for everyone on the unit circle. This is like mind-blowing to you. The unit circle is placed on a Cartesian plane. You just didn't realize that sometimes. I didn't know that people didn't realize it. But this here is the y-axis, the straight up and down line. This here, that's the x-axis. Do you see that? And this is 0, 0. Welcome. Yep, true statement. So this is literally, if we're paying attention, this is the Cartesian plane. When x is 1, x is negative 1, y is 1, y is negative 1. So this is like blown right up. This is like at 300 times. This is like Hannah's test.
She's coming after me.
Yeah, I have to. Because I knew you could take it. Yeah. I wouldn't do it to... Actually, I probably would do it to most people. Yeah. All right. So this is just blown up 1, 1, 1, 1, right? This is just literally if I took like a Cartesian plane with the little boxes, correct? This is just the little boxes all the way around 0. That's it. Like just a little 1 by 1 by 1 by 1. Does that make a little more sense? Literally, that's all it is. So if I drew like the 1 by 1 box, it would be like, whoop. Pretend that's straight. Pretend that's straight too. That's like the 1 box. That's like on a Cartesian plane, on the little graph paper, it's 1 block, right? Then this would be 1 block, 1 block, 1 block. Make sense? So that's why these coordinates are easy to tell, because this is a radius of 1, this is a radius of 1, radius of 1, radius of 1. True statement? This is the coordinate 0, 0, right there. Yeah? So what's this coordinate at? 1, 0. It's 1 over, none up. True statement? 1, 0. Just filled it in because I'm a rocket scientist. I'm not. I'm just a basic math teacher who probably was dumber than you in high school. But you don't know because you can't see my report card. Sucks for you. All right. 0. What's this one going to be? 0. 1. Because we went up from 0, 0 up. So 0, 1, yes? Now we're at 0, 0. We're heading 1 this direction. Where are we at? I really don't like that this is so big. You were just tested. It's fine. So this one here is negative 1, 0. And what's this one?
0,
Still my heart. Okay, ready? We're good. Whew, I was scared. I thought someone was on the phone. They weren't. It was a false alarm. All right. So in quadrant 1, our signs are what? Positive, positive. True statement. In quadrant 2, our signs are what? Yes. So I would go here and I'd be like, boom. This is what I'm going to do. I'm going to erase this because it's confusing right now, but it's fine. I am going to go and say, no, green screen. Yeah. And I'm going to say x is negative. X is negative. X is negative. I did that. I'm right. Okay, cool. Quadrant 3, what are our signs? Yes. Mm-hmm. True, true. Negative, negative. Mm-hmm. Yep, yep, yep. Yes, yes. Yeah, uh-huh. Okay. Quadrant 4, what are our signs? Positive, negative. Our x's are positive, our y's are negative. Boom, boom, boom. The rest is the easy part. Ready? At 45s, we actually were taught last year at a 45 that your triangle lengths across from the same angle are actually the same. So if you looked at a 45-degree triangle, like this, let's say. 45, 45, 90, yeah? The side length across from here is going to be the same as the side length across from there. These side lengths will be the exact same because side lengths across from angles that are the same. Yeah? That's why your coordinate at 45s are the exact same x's and y's. They're root 2 over 2. So I go to my 45s and I say, cool, root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. Now I'm a rebel, so I'm going to keep going. It's not what a rebel would do. That's fine. Root 2 over 2, root 2 over 2. Now here's another 45. Root 2 over 2, root 2 over 2. Now this is where people fall off the wagon. Okay? You should not, because you just use your brain cells, and I promise you, you will not fall off the wagon. The options for 30 and 60, one of them is a root 3 over 2, and one of them is a half. Yes? Then people are like, oh no, 3, 2, 1, 1, 2, 3, or like, okay, I have to memorize. Blah, blah, blah. No, you don't have to memorize it all. One of them is root 3 over 2, one of them is 1 over 2. True statement? These are coordinates on a Cartesian plane. Mind-blowing that people don't know this. And to be honest, I taught it last year and they didn't take it in. Because it's just too much information to take in grade 11. When you hit grade 12, you kind of have a basis, so you can actually take in more. That's what it is. So, these here are coordinates. Do you see this? That's a coordinate. In like my Cartesian plane, remember I have like a block, a 1x1 block here? So 1x1 block, yeah? It's a coordinate in quadrant 1. There's actually a ton of coordinates between 0 and 30. People are like, I can only answer 30s. Well, no, you can answer a whole bunch more. Like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Like there's a whole bunch more in there, correct? But if I ask for exact values can only be the 30, 45, 60, 90s. Okay? Now, that one of them is going to be a half on a 30 and one of them is going to be root 3 over 2. I know that's a true statement. Then people memorize wrong. Why you're memorizing, I'm not sure. Because this is literally a coordinate. True statement? This is a distance of 1, right? This is a distance of 1. So from here to here, 1. From here to here, 1, right? This here, my friends, is a coordinate, yes? One of them is going to be root 3 over 2, and one of them is going to be a half. A half is 0.5. So 0.5 is like halfway from 0 to 1. It'd be like here-ish, right? Or here-ish, yes? So I go and look at this coordinate right here. Look at this coordinate. Isn't it crazy? So of course, the x, that's a half, right? Blatantly. Like from here to here, that's half the way. Obviously, right? No, it's obviously not. So is my x the half? Is my x the half? No. If you put root 3 over 2 in your calculator, root 3 over 2 is 0.8660. Does this look like possibly 0.866?
Yeah.
Yes, that's the what?
Root 3 over 2.
Yes, it is. So this is root 3 over 2 for my x. Let's prove that my y is the same. Oh, let's follow it over. What does that look like? Half. My little yellow was a little off, you see. But it's a half. Actually, I'm kind of going downhill. Well, it's meet in the middle. That's half. Still not 0.866. True statement? Huh. Do I need to memorize it or just understand that that's a 1 by 1 block? It's a 1 by 1 block. So the 30s are root 3 over 2.5. I already have all the signs. Root 3 over 2.5. I just fill them all in. Root 3 over 2.5. Root 3 over 2.5. Now the other ones are opposite, but we can prove that we're actually correct. So, if I go to this one, and I follow the x down, well, that looks like about 0.866, right? Obviously. That looks like 8.866 when this whole thing is 1. Oh, wait, no, that looks like half. So the x is a half. All you memorizers who memorize backwards, or 50-50 guess, that's a scary place to be. Because this is half. I don't know, I got an accent when I said it there, but I got a half. Then this here is what? If this is up to here is 1. What does that look like it could be? Not a half. So it has to be root 3 over 2 by fact that it could be 0.866. Okay, cool. Half. Root 3 over 2. A half. Root 3 over 2. At all the 40, that's 60s. Half. And I already put the signs in, so I didn't have to overthink my brain matter. I already have signs in. Voila. So, if I were to draw this on graph paper, this is my 1 by 1 block on graph paper, right? That's what graph paper looks like, tiny like that. Your unit circle would be like this on your little piece of paper, and then your graph like would just like keep going farther and forever. Like it's literally just, I don't know why I went harder about that. It's a 1 by 1 block. Do you see what I'm saying? It's literally the 1 by 1 by 1 blown up onto a big piece of paper, so you're not writing really tiny. Does that make sense? Good. Good talk. All right. You're going to be able to convert forwards and backwards, and you're going to need to be able to convert forwards and backwards. For conversions, and I put this at the very top of your notes, it's going to come up again later, but I always put it at the top of my notes. Dr. Pot. You're welcome. On the notes. Dr. Pot, which is degrees. If I'm converting degrees to radians, pi on top. I have RD POB as well, radians to degrees, pi on bottom. I made that one up myself. I'm really good at it. But it's just the opposite. So if this one is pi on top, the other one is pi on bottom. Now, the unit circle, we have seen, and I'll tell you this, that it goes to 360. True statement? 360 in radians, you guys, is 2 pi. These are equivalent. So I can make a ratio out of them. And you've done this in physics too. You've done this many times in physics where you have like kilometers and meters or whatever, and you make like your ratio of what they are so that you can convert as long as the way, and you cancel off like terms and it converts it. So you do it with hours and minutes. I remember in science 10. But anyways, 360 over 2 pi would be the ratio, correct? Which it can reduce. You can take 180 out of both of them. Or 2 out of both of them. I don't know if I said 180. You can divide them both by 2, and you get 180 over pi. But you could also multiply technically by pi over 180. It just depends on what unit you're trying to get to go away. If you think about it that way, it's easy. Remember how you wanted, if you ever wanted to convert between hours and minutes, you would say 1 hour is 60 minutes, and you do the ratio of 1 over 60 or 60 over 1, depending on if you wanted to get rid of minutes or hours, because you had to have 1 on the top and 1 on the bottom to cancel off the units. You do that in physics. Same thing here. So if I have 30 degrees, I'm going to either memorize the formula, which means pi on top, so I'm going to multiply by pi over 180, or I'm going to say to myself, when I don't have degrees, I don't have a degree symbol. Crazy, I know, right? So radians, actually, you do not have to put any units behind a radian. So if something was 7, I would say that's a radian because it doesn't have a degree symbol behind it. So that's why the degree symbols are so important. Could you say 7 radians? Sure. Could you say 7 rads? Yes. Could you just say 7? Yes. Radians do not need to have a unit. Okay? So if I want to convert to radians, I know I need to get this degree symbol to go away. And I know that I'm either multiplying by 180 over pi or pi over 180. Correct? I need the degree symbol to go away. If I multiply by 180 over pi, I'm getting a degree times a degree. Degree squared? I'm not even sure what the heck you would happen when you do that. So that's why you multiply by pi on top, because we're going to multiply by pi over 180. And what happens when you have a degree on the top and a degree on the bottom? The degrees cancel off. Right? Then we have radians, because radians is no, you don't have to have anything in order to have a radian. So we have, technically, 30 pi over 180. If I type pi into my calculator, what's going to happen? Can it ever turn into a fraction? Can you turn non-terminating, non-repeating decimals into a fraction? No, they're irrational. You can only turn numbers that don't have pi's in, correct? So if you reduce this, you could say, oh, I could take a 30 out of both. Okay, that would get me pi over 6. True statement. But you can also, your calculator will do it for you quickly. You can go 30 divided by 180 in your calculator. Try it out. 30 divided by 180. Now, why can't I put the pi in? If you put a pi in, you ain't getting a fraction out. No matter how hard you press the math enter button. No matter how hard you press the math fraction button, it's not going to give you a fraction because it can't. You put a pi in, you cannot get a fraction. Okay? So if you go 30 divided by 180, math enter, the math button, enter, it kicks it out as what? 1/6. But we have to put the pi back. We just didn't put the pi in, or it wouldn't have reduced our fraction for us. So we get 1 pi over 6, or we could write it as just pi over 6. So that's why you end up multiplying by pi over 180 or 180 over pi, because we just made a ratio of 360 and 2 pi, because 360 and 2 pi are the same in degrees and radians. They are. I could say pi and 180 are the same in degrees and radians. So it's the same as if you said 1 hour is 60 minutes, and you put them as a ratio on your paper in physics. It's the same thing. Okay? Radians and degrees are the same. They're just a different standard way of measuring, just like minutes and hours, or meters and kilometers. That's it. Okay? So, if we go back to our unit circle, I can literally just take this number divided by 180, math enter it, and add a pi. So I get pi over 6 for this one. We just figured it out. This one, I go 45 divided by 180, math enter it. You'll start memorizing them, trust me. It's 1 over 4. Then 60 divided by 180, math, enter, enter. Pi over 3. This is a 90. 90 divided by 180, math, enter, enter. Pi over 2. So you fill in all the rest and we'll see if you get them right. So for 120, you should have gotten 2 pi over 3. 45, you should get 3 pi over 4. 150, you should get 5 pi over 6. 180 is just 180 divided by 180 and then add pi, so it's just pi, or 1 pi. This one is going to be 7 pi over 6. It's going to be 5 pi over 4. This is 4 pi over 3. This is 3 pi over 2. And then we get, brain's blank. 7 pi over 6, 5 over 4, 4 over 3. This is 5 pi over 3. And then 7 pi over 4. Is that right? 315. I don't know that one. 7 pi over 4, right? Okay. I was questioning myself. No one was assuring me. And then it's 11 pi over 6. Do you ever do something and then your brain starts falling out and you don't know what you were doing and then you kind of question yourself? I do that often with like past students from like 12 years ago. They walk up to me and I'm like, hi, whatever, hi, Kate. And then they walk away and I'm like, what if their name's not Kate? But it came out as Kate, so like I obviously remembered Kate, but then I second guessed myself the entire time. And often I know like their whole name. They'll be like, hi, Hannah Morton. And then they'll walk away and I'll be like, why did I do that? Why did I say the whole thing? Why did I just say hi? Why did I even put their name out there? Why didn't I just like, why? Sometimes it's been 16 years and I'm just impressed that I slightly remember, but then I'm sketched out as if I'm wrong, you know? 2 pi. I sidetracked to let people have time to write it down. So, you know. Did everyone get it? Everyone's matches? Put it in your clear sleeve thingies. Does it match? I am going to give you the next 10 minutes to do these 4 questions from transformations because we don't want transformations falling out of your head. Okay? You're going to do the 4 questions, and on the bottom it has the answers. If you don't get these answers, you're wrong. Ask. I'm like, I'm sure she meant to put a 3 instead of a 1. It's totally fine. Standard position is when we sketch angles called rotational angles on the Cartesian plane with the initial arm where the angle starts on the positive x-axis. You will always start on the x-axis. Last year for most of you, we only rotated in the positive direction, which is counterclockwise. Starting on the x-axis, rotating counterclockwise, which is what we just did on the unit circle. The unit circle, we only did positive rotational angles. We started at 0 on the x-axis, went 30, 45, 60, 90, blah, 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 blah. We went counterclockwise till we got to 360, correct? Could we have kept going? Yeah, 390 would have been the next 30, right? We can keep rotating and rotating and rotating and rotating and rotating to like 10,000 degrees if we want to. What we're also going to do this year is we're going to rotate clockwise, which just is negative degrees. So instead of it being positive 330, that's negative 30. So you're just going, instead of going counterclockwise from x, you're going clockwise, and it just gives you negative angles. That's it. It's not anything like crazy, okay? So, positive rotational angles, if I wanted you to draw let's say 170 degrees. Now some people say, but that's not on the unit circle. I can give you degrees that are not on the unit circle. I can only ask for exact values if I ask for something off the unit circle. But I can say what's 170 degrees, draw it, right? It doesn't have to be one on the unit circle. So what I always do first is I label. So I know that I'm always going to start on the x-axis, 0 degrees. If it's negative, I'm going to write negative 90 down here, but this is a positive angle, so I'm going to go counterclockwise. This will be 90. This will be 180. This will be 270. 360. Could I keep going technically? 90 more, yep, 450, 90 more. I could keep going. I could just keep labeling and labeling and labeling, right? When I go to draw angles, I always rotate about the center. So 0, 0, right here. This is my little, like, you know, you used to do these in elementary school where the teacher would give you one of those, like, metal things and you could poke it through the paper, and then you'd fold out the bottom, and then you could put a spinner, and you could make a spinner, and a little arrow could float around, and you'd see a spinner. Yes. This is just not as cool. This is just a fake spinner. But if I did give you a spinner and you could draw, maybe I'm going to do that. Let's see. That would be some fun. You could actually visualize it. I think I'm going to do that. New fact. See? Learn new things every day. Been doing this since 2012. I've been teaching since 2006, but the new curriculum came out in 2012. 3 times since then, a year at least. But this year, spinners. Unit circle spinners. I like it. Because that, yeah, I do. I like them. Tonight. That's what I'm doing. Staples. Don't fail me. All right. It'll be so, you just don't even know. Like right now, I'm pumped. Not even joking. Like you can't see my face and show, but I am. It's like Christmas. But today. All right. It's Pi Day tomorrow. Spin. Get better than that. Do not skip tomorrow. It is going to be riveting. All right. You can get pie for $1. I think it's $1. You can buy pie. It goes towards, that's for tomorrow. It goes towards Mission Costa Rica, I believe. Yeah. I think it's for $1 tomorrow. Isn't it $1? I believe it's $1. Here.
Cafeteria or what?
I'm assuming the atrium. I'm assuming the atrium. It's on the announcements. Isn't it $1? I think it's $1. I will check it out in a second. Pretty sure it's $1, because I was blown away at the price. But it goes to the children. So I would have thought too. Would have been something, but whatever. Yeah. Okay. Alrighty. So that's, yeah, there's snow cones on Wednesday. So do I. Yeah. Yeah, I love her daughters too. All right. Totally sidetracked there. So we're going to do a plug for Kona Ice. It's great. I just did a plug on my podcast, and it is riveting. Like, so many people watch this. So, like, it's going to, like, take off due to this podcast. I know. With all the 4 people that watch it. That might be maxing out. It might be 1 or 2. But that's okay. So, when we start this, we would have our little spinner arm. Pretend that's perfectly on the x-axis. It looks shady, but oh my gosh, it's getting worse. It's a straight arm on the x-axis. This is called the initial arm, because it's where you initially start. I know, mind-blowing. All right, then we are going to 170, which is how many away from 180? 10 degrees. So obviously it's here. You guys do this to me. This is what you do. Or you're like, it's not that bad, Lepp. I draw it here. I'm like, that's equally as crappy. 10 degrees, remember that's 45, right? Right up the middle is 45. 30 is like a touch lower. 10 is like, meow, here, and it makes that noise. Cool. Now, if you just draw me some arms, you're like, I got this, Lepp. You don't got it if you just draw me some arms. Because remember, we ain't in grade 11 anymore. We're also not in Kansas. I've never been in Kansas, but I'm not in it anymore if I was in Kansas. You know, Toto, you know. Yeah. Anyways, so we have to draw an arrow telling what direction we are going in. True statement? Counterclockwise, positive angles. Clockwise, negative angles. True? It is a positive 170. That is all you have to add. And then you can write 170 here if you'd like. This is 170 degrees. Whoop, whoop. Literally it. Okay. Now, negative rotational angles. I'm just so good at drawing straight lines.
It's crazy.
Yeah, I didn't use the straight line drawer. I'm just that good. All right. We need to label because it's negative. I'm going to get you to draw negative 246 degrees. So we start here and we say 0. Then we go clockwise. This is going to be negative 90. Trust me, we need to label our angles so that we know where we're going. This is negative 180. This is negative 270. This is negative 360. We still start on the x-axis and we still rotate about 0, 0. I drew that perfectly and it didn't let me. We're just going clockwise now, right? Now, how far is 246 from 270? Because that's what I'm going to look at. 24. 24. So 30 is like a third of the way, right? So 24 is like 10 that straight. That's 24. You could also say, hey, it's 66 more than 180. So 66 more than 180. But what I have to do is I have to start there, rotate here, and show that I'm going clockwise because it is negative 246 degrees. Nothing crazy. Now, because we've already done this, we're going to get to this, but we've already done it because we're geniuses. Convert those to radians. Go. Convert the 170 and the negative 246 to radians. Because we have to be able to convert back and forth like in our sleep. Trust me. Most of you will live in degrees, even if I want you to live in radians. And people fight radians because you are taught degrees as a child. If you were taught radians as a child, you'd fight degrees, right? It's just what you're used to. Radians only work in word problems, though. Degrees don't. So we can't just get away with doing degrees. Also, calculus is completely done in radians. So if you do Calc 1, it's all in radians. Degrees are gone. All right. So I want to convert. I'd go 170 degrees. I want the degree symbol to go away. So I'm going to multiply by pi over 180. Because I either multiply by 180 over pi or pi over 180. But I multiply by this so that the degrees cancel off, right? And so I'm left with 17 pi over 18. Now this one, I do negative 246 degrees times pi over 180 degrees. And what do we get when we reduce them? Okay. Negative 41 pi over 30. So not crazy. The terminal arm is where the angle ends. Where the angle ends. Pretend there's an S there. If not, put your own S. And it can be in any quadrant or on any axis. What angles correspond at each axis? We've labeled them above already because we are rock stars. Good job. Okay, I want you to do this. Go.